Steve Morgan. I'm the president of CGen Green Energy LLC. I've got my two partners with me, Darcy McIntosh and Jim Stewart, here today as well. And I've also got my noise solutions partners who are going to do our manufacturing here, Scott McDonald and the business development team. So there's always been a need for electric power on a natural gas facility for lights, gas detection, PLC, heat trace, etc. Most of the facilities here in Marcellus supplement their own power generation by using some sort of power generation, such as turbines, thermal recovery, those types of things. Is it that one? Okay, perfect, thank you. So CGen is proposing that there's a better way. A way that is cleaner and a way that will not disturb the footprint of the facilities themselves. The cooler exhaust of a typical 1,500 horsepower gas generator, gas compressor, is going to produce around 230,000 cubic feet of air exhaust off the cooler. That is going to be moving around 25 to 30 miles per hour. What if we could take a turbine and put it into that airflow and produce energy? Where we started, we actually started doing a lot of testing. We looked at the Darius style turbines. We looked at Savonia style. The Darius was really a challenge. It was supposed to be the better performing of the two. But what ended up happening was that it would not self-start at all. We tried to spin it, all those things would not self-start. And we turned to the Savonia style, even though historically it has not been the best capture rate for energy when it was put out into the regular environment. But when we started to look at putting it into this venturi, this extension of the cooler itself, we started to find some great improvements in the power output, the RPM, and we improved the performance by 64% over what it would be like just sitting out in the same wind, just out in the environment. And we tested those things as well. As we went through these tests, we looked at the RPM, we looked at the torque, we started to do the forecasting as far as the power output was concerned as well. And what we actually have learned is that with a Savonia style, we can get self-start, so as soon as that thing the wind hits that thing, that exhaust hits it, it just takes right off. Spools up in about 3 seconds. We've increased the performance of that particular turbine by 64%. Part of it is because of the way the turbine is situated in the box itself, in the venturi itself, the wind can no longer avoid it. And what it does is actually get captured by it, and we offset it off of the cooler itself, so only the capture side of the revolution is actually in the exhaust. The resistance side of the revolution is offset, and it really increases the performance even more so. We have very low back pressure measured at only 0.005 inches of water gauge at the entrance to the CGen unit. We're forecasting to get around 6 to 8 kilowatts of power off of that particular wind. And of course, we found as in most things, size matters. The bigger the turbine, the better. So we're looking at around a 7-foot turbine. The first ones that are going to go on are going to go the full length of the cooler, and then we're going to start to backwards engineer from there. Maybe we're getting a 2 to 3 kilowatt package on a half of the cooler itself, and the 6 to 8 on the full size itself. Some of the great applications, of course, remote facilities. In the state forest, no power grid even available, this is a great application. Applicable to new and existing facilities, it's an easy retrofit. It actually goes on in about a day as far as the install is concerned, and depending on the scope, day to 2 days afterwards as far as the downstream from the CGen unit itself. Supplement your power needs on your facility. Increase your facility for expansion. So if you don't have to put that power generation unit on that site, what can you do with that extra CO2 footprint? Can you put another compressor on your site? It's a scalable design, as I was just saying. We can power additional things such as your ventilation systems. A lot of the acoustical ventilation systems that go out there, you're going to have a drain of around 2 to 3 kilowatts on a typical 1,500 horsepower unit. This would definitely supplement that at 6 to 8 kilowatts. Lighting, gas detection, heat trace, and your PLC will also be able to be run all from these CGen units. Basically, we can take a facility and take it off the grid or not have to use the grid in the first place. CGen advantages. At $285,000 a mile usually to install overhead lines, the CGen unit is an immediate fix to this situation, and you don't have that big amount of output of cash. You also don't have to wait for it. There's a great return on the investment. Anywhere from immediate, if you don't have to put that grid into, you have to put that overhead power lines into place, or the fact that in about 2 years, it's just going to pay for itself anyway with the power generation that it actually creates. No change to the facility footprint. It just goes on top of the cooler itself. There's no piles, there's no foundation, nothing like that has to be added to it. There's a great piece here for the CO2 as well. So if you put a 7 kilowatt application of one of these on, you are going to reduce the CO2 footprint of that facility for each one by around 75,000 pounds if your power is coming from gas-powered power generation. If you're using coal, it actually doubles that number. And in a lot of places, there's actually tax benefits for those types of things as well. We're going to create jobs in Pennsylvania: business development, manufacturing, assembly, engineering, design, etc. 10 times the power of a comparable type of investment. So in thermal recovery, at around 40,000, you're going to get around 500 to 700 watts. Now we're talking kilowatts instead, 6 to 8 kilowatts. So nice increase in the power output. Of course, it's just a great story of merging fossil fuels and green energies together, which we're all continuing to look for, most of the companies today. CGen development status, so where we are right now today. A typical 10 kilowatt unit is going to cost about $65,000 to have installed, plus the engineering and the actual field work. We've done extensive market studies. We have been working with a lot of clients, packagers, upstream, downstream. The interest seems to be huge. It is all the scale prototype testing has already been done, so we have done extensive testing on a smaller unit, which is actually out there right there, outside of the booth that we have. All of our CFD modeling has actually been completed as well to predict torque, RPM, vibration, wear, turbulence, etc. Our first 10 kilowatt CGen unit is currently in production, is about to be installed in probably the late of this month or early June, just depending on how quickly we get it finished up. Manufacturing has been secured in Pennsylvania as well. We're looking to generate about 15 manufacturing jobs along with engineering, design, business development, etc. Who are our clients? Upstream, downstream, the packagers, EPCMs. We have been in front of everybody. We're very well connected in the industry itself, and there seems to be a huge amount of interest on this. If you look at it globally, we've even been getting some interest from the Middle East. We've been getting some interest from Australia and all over the United States and in Canada. Future projects, we want to continue to improve the CGen unit. Right now we're using the Savonia style. It's going to give us some great results. We want to continue to look at other types of turbines. We want to look at HVAC. We've got to go, our next step is going to be the horizontal packages for the gas compressors themselves. And we've been talking a lot with the mining companies as well, look at their ventilation systems on the underground mines. They're moving about 600,000 cubic feet of air per minute off of these ventilation systems. There's a great amount of power that's just being wasted there. Look at gas turbines as well. In the end, we just want to tell a great story. We want to be part of the change. Our vision is for CGen Green Energy LLC to write and tell the great story of bringing fossil fuels and green energies together. Through disruptive technologies to exploit these wasted energies, we can be an instrumental part of this change. Thank you.
Perfect. All right.